Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting topic in wireless sensor networks. We're going to see Telosb Mote features. In this video, we're going to see Telosb Mote features and its applications. And before going to this video, we already seen various concepts in WSN. We have seen the applications of WSN. And very importantly, we have seen what are the important components of wireless sensor node. If you take a single wireless sensor node, you'll have microprocessor or microcontroller, or you'll have analog to digital converters, you'll have sensors, you'll have power management, and you'll have an external memory. All those are very essential component of a single sensor node, right? And as the technology progressed, there are different companies evolved to produce different platforms for this sensor node. And today we're going to see about one particular platform which is Telosb Mote features, right? Telosb Mote. First, let me tell you what is Mote. Mote is also called as a sensor node. That is, a sensor node can also be called as a mote. And various companies have designed different platform for this particular mode. And this Telosb mode is designed by one particular company which is named as US Berkeley. US Berkeley is the company which designed this particular mode. And this is the same company which designed this Tiny OS. Tiny OS nothing but tiny operating system that is designed to work for self-configurable large-scale wireless sensor networks. And this particular platform also supports the Tiny OS. And in this video, as I said, we're going to see different features. What are the various features of Telos and what are the different versions of it, right? And first thing is, this is the basic Telosb Mote platform. We have different version of it where one version is 2400 GPR 2400, another version is 2420, and the only difference between these two things is this is the basic architecture and this is the architecture where it will have sensor suite in it. And apart from that, this is the very basic features of a sensor mode, right? A Telosb sensor mode. That is, it supports 802.154 complement, which is nothing but Zigbee. It supports Zigbee technology. We know that Zigbee is the very essential technology for wireless sensor networks because of its low power consumption, right? And the data rate it supports is 250 kbps, and it has a microcontroller of this version with 10 kb RAM, and that's an integrated onboard antenna, and it has a data collection USB interface, and it has the open source operating system, and it has the optional temperature, light, and humidity sensor, right? And very importantly, this Telosb mode is a low power consumption platform where we can use for mainly for two particular reasons. One is for research development, and also it will be a good platform for research development, and also for WSN experimentation, that is wireless sensor network experimentation. Right, that is the main purpose of this particular platform. We can do a lot of experimentation with WSN, and also it can be used as a research development platform, right? And before going to see different features of Telosb mode, the main thing in wireless sensor network is energy consumption, right? And this Telosb mode also support different duty cycle operation. That is, it goes to sleep mode to save the power consumption. A lot of features in that, right? And as I said, this is the application of Telosb mode where it is a platform for low power research development, and it can be used for wireless sensor network experimentation. And this is the block diagram or the architecture of Telosb mode, where this is one particular version which is TPR 2400, and there is another version which is 2420, right? Where this particular version will have sensor suite in it where we can able to integrate different sensors. And here you don't have sensor node. This is the basic version, basic mode architecture, right? And you'll just need to explain this particular block diagram where, as I said before, the very important thing is it supports Zigbee, where we know that in WSN, Zigbee is the main wireless technology which we use for uh, low power transmission, right? And here it also supports this 802.154 radio, and it has an embedded antenna to it. And very importantly, it has the microcontroller, and it has analog and digital I/O pins. And this particular mode has two AA batteries, and it will be the main power supply for it. And we have also have a USB connector where, uh, like normal USB devices, we can able to connect with the system. And when you connect to the system, this particular uh, mode architecture will not need any particular batteries in it, so that we can able to save energy. We know that in WSN the main challenge is energy consumption, right? And also it supports different versions, that is different modes of operation, where it can go to sleep mode, so that it can save more energy as well, right? And apart from it, the very important thing, it has connectors and jumper pins through which we can able to connect external devices, and also it uses jumper pins to control the analog digital converters, right? So this is the very important features of it. And apart from it, as we discussed earlier, the other important features are, it is used for research development and WSN experimentation. And as I said, it supports IEEE 802.154.4, sorry, 802.154 radio, and it has low power memory extended, and it supports a sensor suite in this particular version, and has integrated antenna offered, right? And these are the advanced features which we just discussed. That is the very accurate features where it works in the ISM band in 2.4 to 2.4835 gigahertz. It supports 250 kbps data rate, and we have already seen about the antenna integration. And main importantly, it consumes only low power, and the external memory is 1 MB. And as I said, it is an optional sensor suite, where in one particular version you'll have the sensor suite where you can able to integrate different sensors. And this particular Telosb Mote will use this particular platform, that is operating system platform, Tiny OS platform. This Tiny OS platform is specifically designed for large scale self configurable wireless sensor networks, right? And here it is the same company which designed this particular operating system, and so this desktop board will support this Tiny OS, right? And apart from it, as I said, you have two different version of it, right? And in one version the only difference between two versions is the sensor suite is the only version. Apart from it, everything is same. You can see the comparison between two Telosb versions. This is one version. This is the basic version, where this is the advanced version where you have sensor suite in it. You can see the processor performance, flash memory, serial flash, configurable EEROM, serial communication, analog digital converter, digital to analog converter. Everything will have same configurations, right? And you can see even the RF transceiver which we use, right? Everything will have same configuration. Only one difference here is the only difference is sensors. That is this particular version, right? 2020 version will have sensor suite in it, where we can able to integrate the IR sensor, humidity sensor, temperature sensor, all those things. And this version will not have any particular sensor suite in it, right? So this is about Telosb feature. And today we have seen the important architecture of Telosb Mote, and this particular video will be very useful for you, because this particular concept is not in any books, so you can use this particular PPT as your reference for your exams, right? Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.